Hi, my name is Scott Cheatham, and I am a teacher with the Richmond Hospital Education Program. And this is a lesson on solving for right triangles using trigonometry. This is a topic that first comes up in geometry, but then you certainly expand upon it in a trigonometry class after Algebra 2 and moving beyond that. The other important part about this is for both the SAT and the ACT, they both incorporate questions to where being able to solve for triangles using right triangle trigonometry is very helpful. And so this is a skill that as you start to learn and become more comfortable with it is going to stay with you throughout your high school math experience. And just a little bit of a refresher on some terms, depending on how much information you've learned about trigonometry beforehand. But trigonometry at its basis is using ratios. And ratios are just comparing two numbers. Can be written as a fraction, can be written with a colon. We're going to primarily think of them as fractions and how we're going to use them. But there are three basic trigonometry ratios, and we're going to talk about what each one of those references. The three first ones, and you might have heard these, or if you've ever looked at your calculator, you've seen these abbreviations, are what we call sine, cosine, and tangent. And that's what you want to call them. You don't want to call them the abbreviations that you see. Anytime you're saying these, you want to say sine, cosine, and tangent. The abbreviations and what you see on a calculator looks like sin, cos, and tan. Please don't call them that. We always want to call them sine, cosine, and tangent. And these ratios depends on which sides of a triangle that you're using. Now, sine, cosine, and tangent can exist as a ratio for any type of triangle. But the triangles that we're going to focus on, and the only types of triangles that you cover in the geometry class, are right triangles. So triangles with a 90-degree angle in them. So here's a picture, and you'll notice the top of this page, it has a bunch of letters, and if you've never heard it before, it might sound kind of weird, but what we call that in geometry is a mnemonic device, a learning tool that gets referred to as SOHCAHTOA. And what that is that's a way of remembering, okay, what sides and ratios are we going to use for sine, cosine, and tangent. And if you look at this picture, we have three names of how we're going to refer to sides. The one that's going to always be a constant is what we call the hypotenuse. The hypotenuse will always be the side across from the right angle. The hypotenuse also happens to be the longest side. So in a right triangle, the hypotenuse, that side that's across from the right angle, will always be the longest side. There's no way you can make a right triangle without that hypotenuse side being the longest side. Now, the other two sides, the opposite side or the adjacent side, really depend on what angle you're looking for. So here for sine of A, when we're looking at what the opposite side is, you'll notice that it's this lowercase a in green. Now, if we wanted to think of the opposite side, if we were thinking it in terms of angle B, the opposite side would be a completely different side. So it really does matter when we're saying, okay, what's the opposite side, what's the adjacent side? It really depends on what angle we're looking from. Now, what this ratio, these sides that we're comparing, for sine is going to be the opposite side over the hypotenuse. In this case, for sine of angle A, the opposite side is the lowercase a over the hypotenuse. Now, if we had an actual example here, we would be plugging in the degree measurements for angle A, and then the side measurements would end up happening for A and C. We don't have those, we're just using variables right now, but those values are things that we would plug in. For cosine, it's the adjacent side over the hypotenuse. And so again, if we're looking from angle A, when you look at that, you might want to say, okay, well, couldn't the hypotenuse be the adjacent side? And we don't really consider it that way. The hypotenuse is always a hypotenuse, and so the adjacent side is the other side from that angle. And lastly, we have tangent. Tangent is the opposite side over the adjacent side. And so, again, from these, it really depends on what angle you're looking from as to what the sides and what values you would use. But being able to remember or memorize or use the SOHCAHTOA device, that sine of an angle is opposite over hypotenuse, and that's where the SOH comes in. Cosine is adjacent over hypotenuse, CAH, C-A-H. And then tangent is opposite over adjacent, TOA. That's going to be something that's going to be really important for you to get a handle on and be able to understand where that goes from. As you keep doing this, I promise it will become easier, but that SOHCAHTOA tool is a good mnemonic device to help you as you're first learning these sides. Now, giving you a little warm up here, some things I want you to practice because we're going to use them. For problem 1 there, it says find the sine, cosine, and tangent of each of the acute angles. So in this case, in this triangle up there, angle A would be the right angle. The acute angles are angle B and angle C. Normally we do write those as fractions, but I want you to write them as decimals because that's going to come up in how we're going to do them. And then the next ones are ones I want you to do. This is having some algebra review and how you would solve for things if you had a fraction in those. So I want you to go ahead and pause the presentation here, and I want you to work on these 4 problems. Again, you're going to have, I want you to give me answer angle 1 as decimals, and then for 2, 3, and 4, that's just some algebra review. So go ahead and pause that now, work on those, and then start it back up when you're ready. All right, now for sine of B, again, that would be the opposite side over the hypotenuse, so 35 over 37. And again, if you plug that into your calculator, which is what I asked you to do, you would get those 4 decimal places written there. Cosine of B is going to be your adjacent over the hypotenuse, and then tangent of B is going to be the opposite over the adjacent. Now, when you do the same thing for C, you'll notice a couple of things. I just want you to look at those answers and just make some observations to yourself as to what happens, what's the same. And it ends up being pretty obvious that the sine of B and the cosine of C are the same values. And if you think about that, and if you looked at the numbers you were using for sine of B, the opposite side was the same as the adjacent side for angle C. And so it makes sense that those two would end up being the same values. For the tangents, it's not as obvious when you're looking at these as decimals, but if you look at them back as a fraction, it ends up they're actually the reciprocals of each other. The opposite over adjacent. It's just them flipped. We're going to use these in solving for some values, and the way we're going to use these is actually going to be using a calculator. And so that's why I wanted you to write it out as a decimal. What the calculator is going to give you is going to be them as a long decimal, and so we want to make sure we feel comfortable using those. Now for these are equations that are set up with fractions, and there's a number of different ways how you could approach these, whether you wanted to think of those like 40, whether you wanted to think of that as 40 over 1 and cross multiply, or whether you just wanted to work it out algebraically, keep it without doing that. I really don't mind whichever way you do, but I do want you to feel comfortable in knowing how to do this. I'm not going to go back over this concept from pre-algebra and algebra 1. but we are going to run into quite a few fractions. And the thing to just make sure you're mindful here is where is the variable in the numerator, the denominator. What does that mean in terms of my algebra? And how am I going to solve for these? Answer here is going to be written down there. Hopefully that didn't give you any issues. Now, as I mentioned, we're going to use calculators here to give us some values. And it's going to be important when you're doing this for this introduction kind of unit in geometry into trigonometry, where you're really just focusing on right triangles. We really want to use what's called degrees. And degrees is what you're used to, what you are very familiar with. You've probably not had much exposure to what we call radians, which is something you get much more into as you later on in high school in a trigonometry class. But when you go on to certain calculators, whether that's a TI, Texas Instrument handheld calculator, or even the Desmos calculators, they're oftentimes default to using radians. And so you kind of have to make sure you go on there and click on the settings in the Desmos graphing calculator, turn it from radians to degrees. And same thing, if you have a Texas Instruments one, you have to hit mode and make sure that's in degrees and not radians. The scientific calculator for Desmos is defaulted to degrees. And so you just want to make sure that that is the case when you pull it up. I really don't mind what calculator you use. Any of them are going to be great for getting the job done. I put the links on here for the Desmos scientific and graphing calculator. You're going to want to pick one of those to do, whichever one you're most familiar with. If you want to just stick to the graphing one that you've probably seen more of, that's fine. The scientific calculator has it on there as well. So, how are we going to use these ratios? What is the point of them? And eventually we're going to get into some real world examples, but I just wanted to show you here a triangle with some information. And the neat thing about trigonometry is if I have a little bit of information, I can get enough information for the entire triangle and solve it. You're probably familiar with the Pythagorean theorem. A squared plus b squared equals c squared, and that gets used on right triangles. When you have two of the sides, you can find the third. But here we don't have two of the sides. We have one of the sides and an angle. And what trigonometry allows us to do is it allows us to use this ratio of sides. If I wanted to say, okay, well, for 52, let's say I want to solve for x. Well, from the 52-degree angle there, x is my opposite side. And what other piece of information do I know? Well, I'm given the hypotenuse is 15, so which trig function, if I think to SOHCAHTOA, uses the opposite side and the hypotenuse? And the trig function that does that is sine. So let me show you how I would set this up. Sine of 52, which means I have the ratio of opposite over hypotenuse. Now, what I'm going to do here is I'm going to use my calculator, and it's going to give me a decimal. If I plug in sine of 52 in there, it's going to give me a decimal, and I'm going to use that in order to solve for x. And I'm getting 11.82 as my value for x. Now, I could use the Pythagorean theorem with 15 to go ahead and find the missing side, but I want to stick kind of using trig. For y, I've got my adjacent side y and my hypotenuse of 15. The trig function that uses adjacent and hypotenuse is cosine, so I can go ahead and set it up that way. Now, I do know x, which I could also use tangent. I would just have to use that 11.82 that I just solved. 15 is a nice, more even integer to use, so I'm going to kind of stick with that. But you could set this up a different way. All right, now I want you to solve for these, and I do want you to write out the trigonometry values as you get practice with that. I want you to make sure that you are comfortable doing that one. So go ahead and pause this presentation, and then you can work through that to solve for x and y, the missing values, and then I'll show you kind of the steps that I used for that. So go ahead and pause this now and go through there. All right, so for here, I've got what I would use as my setup for x and y. In tangent, I've got that 8 there, which is the opposite side from 24. For x, I've got, is that the adjacent side or the opposite or the hypotenuse? It's the adjacent. So which trig function uses the opposite side and the adjacent? That's how I came to tangent. Likewise for y, I've got 8, which is the opposite. Y is the hypotenuse. Which trig function uses the opposite side and the hypotenuse? That's sine. And here I have my values. Now, when you plug tangent of 24 into your calculator, you get 0.4452, and it keeps on going. We do want to keep that as to 4 decimal places, or if you just want to store and use the long decimal value, that's fine also. It's not, it might change your final answer 1/100th, but as long as you're showing your work, that's going to be fine. But that's why we do write out the trig value to 4 decimal places. We don't want to round too early and then change our final answer. For this one, we end up getting y equals 19.67. I'm not going to ask you for the rest of these to write out the trig value. I do think with the way, especially the Desmos calculators, you can just kind of store it in there or just type in the trig values and the angles. But if you do want to write it out, make sure that you're not rounding too early. All right, here's problem 2. Again, you've got 8. You got x and y, asking yourself, okay, do I have the opposite, the adjacent, the hypotenuse? Which side am I trying to solve for? And then which SOHCAHTOA, which trig function am I going to use from there? And for x and y, you can see the setups here. Tangent of 48 equals x over 8. Cosine of 48 equals 8 over y. And then here you have your solutions. Now, one of, I think, the neatest things about trigonometry is that it really kind of starts to bring together a wide variety of different math concepts that you've learned up to this point, and really gives you some real-world context for solving them. So we're going to go over how we're going to solve word problems using trigonometry, but there's 2 terms that come up in these that I want to make sure we're kind of thinking about. The first one is the angle of elevation, and you can read this kind of description, but basically the angle of elevation is if you are looking up at something. If you want to think of that as making a right triangle, kind of in this picture, how he's looking up to the top of the tree, it makes a triangle there. The angle of elevation is that angle inside there, x. Now, I will say that I do recognize that if you're looking up at something, your eyes are a couple feet up off the ground, that we're not going to get that detailed with it. You can kind of think of the angle of elevation as being from your feet up to the top of something. Angle of depression is almost as if you're looking down at something. Now, the tricky part with this is the angle of depression doesn't end up in the right triangle that's formed from there. It sometimes kind of can give people a little bit of confusion here. If you look at this picture, the angle of depression is that angle there. And if you actually thought of how parallel lines work, the angle of depression actually corresponds down there to angle A. And so you want to make sure that when you're going through these problems, that when you see that defined, you want to make sure you're putting the angle in the right spot. Now, one thing to note there, the measure of angle of elevation, the measure of angle of depression are going to be basically the same. They're the same angles. As I mentioned, the way that those parallel lines worked before, they're going to be the same. Now, the other angles, because we're dealing with right triangles and right angles here, are going to be complements often of those. And so there's going to be a wide variety of different ways that you can set up these trig problems. But you just want to make sure you're being careful in how you take the information that you're given and plugging it in, using it in the problems. Now, when you're solving these trigonometry word problems, I want you to follow these 4 steps. And as you get more comfortable, you might be able to skip some of them. But really, for all of these examples we're going to go over in the practice you're going to do, I want you to do this. Number 1 is draw a picture. Label the lengths and angle measurements. Now, when I say draw a picture, I don't mean necessarily be very artistic and draw things with great detail. Now, if you want to draw a stick figure or some things in there and you're very artistic, then by all means have fun with it some. But really what you're drawing is a right triangle. This right triangle doesn't need to be to scale because we're not going to be able to make it to scale yet because we don't know all the information. But it also doesn't need to be flourished with all sorts of picture details and drawings around the word problem. It really just needs to be a right triangle where you've labeled in the information that you're given from the problem. We want to put letters on the vertices and assign variables, whether you're using H or X for distances you're trying to find. We want to put that in there. And then you're going to make a plan. So that plan, looking at, okay, what am I trying to solve? What do I have? Which trig ratio do I then use? And then you're going to set up and solve the problem. So here's an example that I'm going to walk you through, and then I'm going to let you kind of go through some kind of on your own that I'll talk through with you. But the Eiffel Tower is 324 meters tall. You're looking at the top of the tower with an angle of elevation of 28 degrees. How far are you away from the base of the tower? Now, I'm going to show you the picture that I drew, and it's a very basic triangle. And so what you can see here is I didn't try and draw the Eiffel Tower, although you can certainly have done that if you wanted to. But I labeled in, okay, we've got 28 degrees as my angle of elevation. The Eiffel Tower is 324 meters tall, so that's going to be that vertical side of the right triangle. How far are you away from the base of the tower? Well, there is my variable. So I'm going to go ahead and put that in as my x. And here is the type of picture I want you to make sure that you can draw so that you can pull out from that word problem this information in this format. This is going to allow you to decide which trig ratios we're going to use and then to solve the problem. And if you look here, I had the opposite side. I was trying to solve the adjacent, so tangent was the right one to use. Tangent of 28 is 324 over x. And then you could use your calculator in algebra to solve. You get 609.36 as your value for x. One last step, though, you want to make sure you answer the problem. So your answer isn't just 609.36. It asks how far are you away. And so in a word problem, we're going to have to use our units. We're going to have to make sure we answer the question. And so you are 609.36 meters away. Now, from here to the end, I have 5 word problems I want you to kind of solve at your own pace. So what I want you to do, I want you to pause this one in just a minute and go ahead and go through it, try and solve it, play what I say back, check your work, make sure you feel good about it, then go to the next one. And so there's 5 problems here that we're going to kind of finish up this lesson on. They use different trig functions, so be careful. I do want you to draw that triangle picture for each one of them. That's really going to help you to be able to get more comfortable with this and make sure that you're using the right trig function. So go ahead and pause, read this one, and then come back, start it. You can check your work and then go on to the next one. So you can see my triangle here and the angle at the ground. It does say the 20-foot ladder is propped against a wall. So if you think about that as the ladder, the 20 feet is actually the hypotenuse, and that's something that's a little bit different. It wasn't saying that it hit the ladder 20 feet from the ground. It's actually a 20-foot ladder. So that's something where, depending on how the word problem is worded, you're going to plug in your values that you're given on a different side. The answer here is 12.04 feet. Here's problem 2, still again using a ladder but worded differently. So go ahead and pause this one, draw your picture, and solve. And again here, it's 5 feet from the wall, so we've got that 5 is down there at the base. We're trying to figure out how long the ladder is, so that's going to be the hypotenuse. We've got our adjacent over our hypotenuse, which means we're going to use cosine, and you get an answer of 16.18 feet. So here you have a bald eagle. It's sitting on a 140-foot tall water tower. The angle of elevation to the top of the water tower is 25 degrees. So how far are you from the bald eagle? And so the bald eagle's up at the top there. It's on top of that 140-foot tower. If you think of distance is going to be the shortest distance between 2 points. So it's from you on the ground up to the top there. So we're going to be solving for that hypotenuse. You got the opposite side, so that's going to be sine. We get 331.27 feet. Now, this one you got to read a little carefully. So make sure when you're reading this one, you're thinking about what values am I going to use. So read this one carefully as you're deciding what values you're going to use in your picture and in your problem. And you notice here, it's a 6-story high building with each floor is 12 feet tall. So you're going to multiply by 6 there. So you actually get 72, which is not a number that was given to you in the problem. So you got to make sure you're kind of reading carefully and not just pulling out 12 as the number that you're going to use. You've got tangent, because we've got the opposite side. We're trying to find the adjacent, and so you find that value is 30.56 feet. All right, this last one here is an angle of depression problem. So I want you to draw this picture carefully and then go ahead and solve. The next 2 slides, I kind of talk through the picture before I get into the solving part. So if it's throwing you off, feel free to kind of look at the next 2 slides with me, and I'll kind of explain a little bit more since this is our first angle of depression problem. So here is how it would look. So you got that triangle. Again, angle of depression is going to be outside of the triangle here. You're standing on hill is 120 feet high. Then you want to, okay, well, how long are you going to sled down the hill? Now, another way you could think about this, let me show you a different way you could have drawn it. So you either could think of it that 120 feet would be over there on the right, or you could take the complement of 35 and treat it as 55, which would be inside the triangle. Either way, it doesn't really matter. It's going to get you the right answer as long as you use the right trig function. This is just giving you some different options as how you look at it and to which trig function you're going to use. So here are 2 ways of solving the same thing. If you use the 35 degrees, it's going to be sine. If you use the 55, it's going to be cosine. If you plug in your calculator sine of 35 and cosine of 55, it gives you the same decimals, and you get x equals 209.21. And again, we want to make sure we answer the problem. So we have 209.21 feet. And so these are just some starting examples of how you can use trigonometry in word problems. There's some other things that you're going to learn. They're called inverse trigonometry if you want to use trig and go backwards and solve for angles. Here, all of these word problems we solve for distances or lengths on a triangle. There's ways that you can use a calculator to go backwards if you have the lengths and define the angles. But using trigonometry really gives you a much wider variety of options for solving for different lengths and triangles rather than just the Pythagorean theorem. And it's a gateway into more higher level math that you're going to learn starting now and moving into Algebra 2 and beyond. So I hope this lesson was helpful. I thank you for your time, and I wish you well as you keep learning more about trigonometry. Thank you.